Hey, Twitter, YouTube, we didn't see you there. Sorry, we were already getting to work. Hey, this is Plutus PBL live coding. It's the 11th of May, 2023. And we get together every Wednesday and Thursday at 14:30 UTC to solve some problems and figure stuff out together. What we do is we just get together, we start suggesting some questions or topics for the day. If there's more than one topic, we do a quick vote to see what stays here on the live stream, and then we jump into the subject at hand. So welcome, everybody. It's good to have you here. What do people want to talk about today? Do we have, oh, good, changing the magic number. I can go in a breakout room.
Yeah, I'm trying to find out which module that goes along with. I think it's a mastery assignment in module
102.
Yeah. And then I had a Harsha. Is Harsha around? Yeah.
I'm here.
Hey, cool, man. I wouldn't mind getting into that to that error that we ran into. We copied it, and there's in my thread in the Discord. What do you got going today, Harsha? Which one? How far are you? Tip of the spear?
I'm doing 201.4 still.
Okay.
Some initial, oops, I just noticed I didn't update that video. Cool. So queries, what's cool about queries as well is we're going to have to make some of them to build transactions. So we might touch on some of that.
And then yesterday, it seems like we were working on scripts, like getting the scripts down, and that might have been 103 or maybe back in 102.
There's a couple of scripts introduced at the end of 102, like these ones. And this, here's the
yeah.
Here. Yeah, does this look familiar?
Yep. Yeah, we were basically trying to get those to work and in our system, but it kind of stretched out our sort of thought on like prompting, and it was kind of kicking out errors but still working. So that one might be fun. I feel like it might be sort of a side quest to the main.
That's excellent. Yeah, these are kind of in generations. So the ones that are mentioned early in the course they actually provide a little bit less automation to kind of make you go in there and start to tinker with how they're working.
Yeah.
Some of the more recent ones are going to automate more. But just a cool thing to understand about scripts is that everything executes sequentially. And so like what you said about it looking like maybe it's partially working,
Yeah.
essentially, this is a dumb list of commands that really aren't aware of each other in any way. Like in JavaScript, there's this concept of a try catch, where you try to run one function, and if it works, great, keep going. And if not, you catch an error and you show that error and you do something else. And that's a process. That's just kind of a shortcut that you could replicate that functionality without a try catch. But here it's basically like, hey, do this thing. And then no matter what, do this, right? Do the next thing, do the next thing. And so down here, for example, even if this build transaction fails, it's still going to try to sign and submit the resulting file. And so what you would see in your terminal is first of all the failure message for this. And then you would see an error message that the file you're trying to sign doesn't exist. And then you would see another error message that says the file you're trying to submit doesn't exist.
Yep, that's exactly what happened. Yep. And that makes sense. Thanks for giving that little bit of clarification. And that script try catch thing, that definitely makes sense. And we could build that into this. I imagine it's just at the moment they're not built that way.
You could like create a temporary variable and say, hey, if the variable is this, et cetera, et cetera. Right. But it would feel really inconvenient because shell scripts are not built for that.
Right.
And it's kind of empowering when you realize, oh, a shell script, yeah, it really is. It's just like giving the computer a to-do list of actions and saying, here, just take care of these.
Yeah, I might, I think, now that I see that up there with my honey badger coin, I'm like, ooh, man, I want to change, but even though I do love the number 5, but I think I might switch it to something even cooler.
An even cooler number, and it's exciting to kind of start to think about the quest nature of this thing, right? And how much of it doesn't even rely on bells and whistles and cute video game characters, but it really is just that motivator for all of us to be like, yeah, I need that. I want to make sure I get that part.
Exactly.
Right. So this, the magic number part, you have a chance to kind of think about scripts as well with that one. Should we do a quick vote on these 2 breakout rooms? Going once, going twice. All right. So we got 2 options today. And we can select from that list. You get 1 vote and 1 minute. And if you don't have access to Miro, I'll drop the link in the chat one more time. But also just feel free to write number 1 or number 2 in the Zoom chat. Here we go.
Oh, man.
All right. If it's got to be an odd number, so there's a tiebreaker. Here we go.
Anyone coming through the chat?
All right.
Dun, dun, dun.
Let's see what we got.
Dun, dun, dun. The moment of truth.
It seems like you get to see the results before you got a faster connection over there.
But yeah, me. Oh yeah, it might be closer to the faucet.
All right. So it looks like we'll stick around in this room to play around with that commitment transaction. Magic number. I'm going to make 2 breakout rooms, 1 for magic numbers and another one just for other if anybody needs it. And then we'll take it away. All right, cool. So let's talk commitment transactions. If you're jumping to another breakout room, see you soon. But these are actually related topics. Both of these are smart contract interactions. Okay. And we're going to look at both of them, especially as we start to specialize a bit more in Plutus. But the commitment transaction, it gives us a nice way to learn more about the DApp that's already being used to deliver this PPBL course, right? You notice at the very beginning that you're able to connect a wallet to the course. You minted a token from inside of it. And all of that is functionality that we can look at closely. And then in module 103, this little commitment component starts to pop up. Okay, it's not there for the first few modules. But let's jump over to the course. Okay. So we didn't even introduce it until module 103. But starting here, whoops, you have the ability to make a commitment. It might look like this, or if you're on a bigger screen, these will be side by side. And when I tap one of these buttons, I can see this little component. This is repeated throughout the site. It's just a single instance of a React component used throughout the project. If I don't have a wallet connected, which I won't in this example, I got to change browsers. Give me just a sec. But that's kind of the idea. And it first shows up here. And here, give me just a moment to switch windows. Right. So once I connect a wallet, I can see whether or not I have the token. And if I do, I can see that here. And I have the ability to make this commitment. When I make a commitment, maybe some folks have tinkered and noticed there's this distribute demo link right here. After you make a commitment, it's visible on this list right here. And we were talking before starting the recording today just about beautiful UIs. This is not trying to be that yet. And part of the reason for that is we want to create spaces for people to play around. So anybody who was in the course last summer knows that one of the things that you might choose to do with the 300 level is take components like these and just restyle them, right? So that's coming up, but the functionality is here, right? And this shows us what somebody committed to, who committed to it. There's some Lovelace and some test gimbals here, which we haven't talked about yet either. And then there's what your data, what your contributor datum is going to be after it's updated. Okay. And so anybody holding a teacher token for the course is able to distribute these things. When they do, they look at your lucky number. And if it's been changed from 5, they'll include module 102 in this list. You can see I just press this button and then this shows up in that datum. And then I would distribute that. But with a lucky number that's still 5, we know that maybe you haven't done 102 yet, and we can remove that from the list. So that's the context, but what we need to do today is troubleshoot, because it sounds like the commitment transaction for module 203 is not working. Ah, the NFT gallery is down too. Excellent. We're going to have to fix that. Let's see, where is the commitment on this one? Oh, here, right, the assignment. Okay. There's just a little bit of conditional logic here. Okay, so everything I just described, you know, you must have the contributor token to be able to make this commitment at all. I can connect, I can see that I have it. Okay. Then there's also some built-in validation here, and this is all front-end stuff that will show you if you have, you know, have you minted that NFT, and you can see I've got the indicator here. So I know I've already done this thing, and I should be able to make a commitment. Now, one last thing. In some of the modules, I think this is the case in 201, for example. Or maybe it was in 202. Sorry. Yeah, so like this one right here, it says you must complete module 201 before you commit to module 202. And this is not completely true, at least from the smart contract validation perspective. And here's what I mean by that. I'm going to connect a wallet, and I forget what mastery data this one has. Yeah, so I broke. Okay, good. There's a couple of errors that need to be fixed. This is awesome. But basically, the logic that prevents you from being able to commit to module 202 without 201 is purely in this front end. And we can look at it, okay? It's just some JavaScript function that looks at your mastery datum. And if it sees that you've completed module 102, it shows you a component right here. But if you know what you're doing, you can still make a commitment, for example, via Cardano CLI that breaks this rule. And that's a really important concept, okay? If we were talking about a decentralized exchange right here, where large amounts of value could be moved back and forth, you absolutely would not gate access to it with just a little bit of conditional JavaScript rendering. And I hope that makes a ton of sense, right? You can't build something that's only stopping people from nefarious behavior by stopping them from doing it on the front end, because if there's value being exchanged, somebody who knows what they're doing is going to go build some transactions with Cardano CLI and take all your tokens. Any questions about that so far? Well, it looks like we have some things to fix, which is kind of exciting. And first of all, sorry for not realizing that this was happening. It looks like when I connect a wallet to this assignment 2021 page, I get a client-side error. That's not ideal. So we can read those errors. Would like to improve that. That's assignment 2021. And then this happened somewhere else just a minute ago as well. Where were we? Was it? Oh, the NFT page. The NFT gallery wasn't working. And so 3 ways to mint an NFT. There's a gallery here, and we're getting an error there as well. So let's fix that one too. Excellent. But before we do any of that, let's do the first thing we talked about doing today, which is fixing the commitment transaction on module 203. So it's this assignment. If I connect my wallet here, this looks good so far. And I'm just going to try to commit to this and see if it works. This commitment transaction, you see how it has 2 contract outputs, okay? One of the outputs is going back to a treasury that's just holding a pool of tokens. And this is where the 10 test gimbals and the 2 ADA come from. And you can see the rest of the gimbals are going back there. And then to this kind of holding, this is an escrow contract that holds the ADA, the gimbals, and your contributor token until the commitment is unlocked. And we can look at these contracts too. We'll go through as much as we have time for today. All right, so that looks like it worked on my end. Oh shoot, was I wrong? Was 201 the one that wasn't working? Sorry, I thought somebody said 203. So yeah, what I see here is that when I tried to commit to 203, this looks like it's working, but let's troubleshoot if that's not working for anybody.
Hi, James. I had a problem with 203.
Oh, great. Hey, Claudio.
Hi, sorry. Listen, I have a problem. If you saw in your transaction, it sends back like 8,000 something T gimbals back to you. It tries to do the same with mine, but I don't have that many. So it fails to build the transaction from my wallet. So that's the problem I have.
That shouldn't be the case. Okay, so those gimbals are coming from a contract address, a treasury contract, but maybe I wonder
So
if there's a
do you want me to share screen and show you what the error
Yes.
gives so you can see it?
please. Yeah.
I don't know how do I share? Oh,
Should be a
okay.
green button at the
Okay,
bottom of the
yeah.
Zoom.
Okay, share. Open. Sorry, I had to.
No, take your time.
I had to allow the system to share. Sorry.
Take your time.
So it should be okay. So. Oh, it tells me that I had to quit Zoom to share. Can I connect back in a second?
Sure. Yep, jump out and back
Okay.
in.
Okay. Okay. Share screen.
Looks good.
So you see my screen? Okay. So here's the commitment. When I do the commitment, see,
Mhm.
I have the same request as you. Oh, sorry. That's for having a too complicated password.
I think about using easier passwords.
I'm proud of you. That takes some courage to type in the password with the screen share on. That's good.
Well, I didn't show it, right? So.
Oh, you're good. Yep. Take your time.
You see, we could not send the transaction.
And what do you see if you go to the console logs?
I managed to, sorry, to look at with the NAMI wallet to see what was going on. And I could see that there was, it was asking me to send this 8,000 something T gimbals back. So I figured that was a problem that my wallet couldn't send it. So I don't know. What would you want me to show you?
You see at the, well, actually, so in the top right of your browser, right next to the logo, can you click on the three lines, the hamburger icon?
Yeah.
And then choose more tools. It's down near the bottom.
Wouldn't be on settings?
No, more tools, 2 lines up.
Oh, okay.
And then developer tools.
Okay.
And then click on console at the top of that window next to where it says elements. And, oh, okay. Hold on one second, right? This component doesn't log our error right now, and that's not a good thing. Give me one sec. Yeah. Okay. I'm actually pushing a tiny fix to this site right now. And it's going to take just a moment for that to be available to us. So while we're waiting just a moment for that, when we look in your log right here, this is what we would expect to see before you sign a transaction. Okay, so for the NAMI window to open up in the first place, we must have at least built a valid transaction with balanced tokens in it. Now, the error reporting that you can see in the alert that pops up right there is not as helpful as we want it to be. And that this is a known issue among the developer community. And one of the things I know that the mesh team is working really hard on right now is to have better descriptive error reporting. And long story short, this involved them needing to go kind of back to the drawing board with how blockchain information is deserialized. And now that they've kind of built that, the error reporting is getting better and better. But in the meantime,
the first
there's
time
kind of two high-level errors you're going to see in the
download.
alert right there. And one of them is going to be what we just saw. Wallet cannot send the transaction.
Right.
And the other one that's common, maybe some of you have seen it, it's going to say validation mismatch error or something like that. And just in case you ever see those, the validation mismatch is a Plutus validator error, right? It means you're building a good transaction, but you're not meeting the rules of the Plutus code.
Okay.
The other one, wallet cannot send transaction, is probably a lot more frustrating because it's a bit more of a mystery sometimes as to exactly why it's happening. But I think we can figure it out.
Should I try again?
Yeah, let me just
Reload?
double check that deployment went through. If you refresh this page, yeah, we're good to go. Okay, so I just added it so we get a better log. So just refresh, try that transaction again, and we're going to be able to read in the console what the error is.
It's not showing up.
Oh, here, you can just close for now this debugger window. We'll get it out of the way.
No, it's just that. Oh, okay. Yeah.
Yeah.
So now I connect again.
All right,
Keeps
so
on-
no surprise here. And you can also press Command Shift
J, right?
and I think. No, I think it's I. Command. I forget what logo. Command, well, whatever it is. Or just open it up again. Yeah,
That's okay.
I don't remember the names of my Mac keys.
No, me neither. So I go again here.
What's that button called? That squiggly line.
That's control.
Okay.
Control.
Yeah.
That's control. Okay. So look, we have this new object at the bottom of your console log there. Press the little arrow. Okay, good. Transaction submit error. And you see that this message is actually pretty long.
Whoa.
One
So
thing you can do, you can actually copy this whole error message and like paste it into a text editor, whether it's VS Code or anything else. Try like right clicking on that error. Yeah, and copy string contents. Yeah.
This one? Oh,
Yeah.
okay.
Yeah, then just if you have like an editor, we can just.
Yeah, I'll just open another code.
In the file menu, there's an option that just says new text file. That's all we need.
Oh, but I only have to show more, so it doesn't copy the whole.
Well, now
picture.
if you press Alt Z, it should wrap your text.
Oh,
Or
sorry.
Option Z.
Option C. Oh,
There we go. There we go. All right. So what the heck? So we see some UPLC there. That's kind of interesting. Oh, what do we get?
It says it's a transaction validation error here.
It does say that. Yeah. So why did it fail? 3arg Plutus script.
The memory budget is overspent.
Look at
There is
that.
mem minus 3,500.
Okay.
Maybe you have too much transactions in your NAMI wallet. Different transactions.
No, I'm just doing the normal things here with the assignments. There's just a handful of them. I can show you. See,
This
not
is
many.
great. So wait, that Adrian, could that error happen just because there's too many UTXOs being pulled in as input based on just from what exists?
Yeah, or maybe he has too much token at the UTXO where the contributor token is locked.
Juan, what do you think?
Maybe he should send his transaction only with the token and some ADA.
Yes, maybe that will solve the problem.
You see, I sent this for this assignment, guys. If you remember, I did have to send it to my Cardano CLI wallet to do the assignment and then recover it. So I did send my token to my CLI, and then after doing the minting of the NFT, I automatically got it back. So,
Yes. Can you throw in the chat the address of that NAMI wallet you're using?
Sure. Yeah. There you go.
I'm just going to look at this address quickly on Cardano CLI, and if it's interesting, I'll share a
Do you want me
screen.
to stop sharing and so you can do it?
Oh no, so I'll just describe to you what I see, and we can come back to this. So what I see for this address is, wait a minute. Oh yeah, okay. No, this looks good. What I was thinking we would maybe see is that your PPBL token was in a UTXO with some other tokens, but that's not the case. It's in its own UTXO, so that's a good thing. But the other thing I notice is that, and yeah, here I'll share for just a moment. It's silly to describe this.
Okay.
We can go back and forth.
Sure. Thank you.
Okay, I was just about to jump out, but now it's getting interesting again.
This is cool. And so I was actually going to suggest that the same thing that Juan did, but I'm not sure how much of a difference it's going to make. And I think we have to try it. But before we do, come on. Yeah. All right. So I queried Claudio's address using Cardano CLI. And you can see right here This is the policy ID. This is his PPBL 2023 token. It says 222 PPBL and then token name. And it's in its own UTXO. We have a sufficient 1.5 ADA as the min UTXO. And there's no other tokens in this one. And sometimes that's the problem, right? UTXOs that hold multiple native assets can lead to problems building transactions. I see a sufficient collateral UTXO right here. And then there's one very big UTXO with most of your spare Lovelace, right? You've got all these UTXOs with minimum amounts, each one with one native asset. That's a good clean wallet right there. But I wonder if it's struggling just because the only source of Lovelace is this big UTXO. Okay, so let's try this thing that Juan is suggesting first, because I think it might work and I'm curious. And if it does, then we'll change it. In your NAMI wallet, can you just send 20 ADA to yourself? It's such an interesting problem because this problem really gets at the heart of what people mean when they say Cardano development is frustrating or difficult. But it also, I can't think of a better way to spend our time together at this moment, like understanding why this is a problem, because yes, there are problems to be solved here, but this is also starting to illustrate for all of us the proactive benefits of building on the UTXO model. And we're still in this moment in history where we have to kind of apologize for it, right? Oh yeah, this is harder than the EVM, for example, for these reasons. But there's going to be an inflection point, and I think it's coming soon, where we have a good, positively framed argument for why building on this model is so powerful. I think we're getting there. I can keep querying this address. Oh, but I just described to you. That go through yet, Claudio? Oh, you're muted, sorry. Hey, I can't hear you.
It's funny. I just tried to send it to myself with the. I send my ADAs to my CLI wallet. That worked, and when I tried to send it to my own wallet, NAMI, it failed.
Okay, there's two reasons why that might happen.
Right.
One is if you already sent to the CLI and that worked, you might have to wait for that to confirm, because otherwise your wallet's going to be double spending your big UTXO. And I have this problem with my node right now that I got to fix. But if I just start it again, we should be able to see. Okay, so there's a different UTXO distribution now in your wallet. Uh-oh. Well, look at this. So NAMI just did something interesting.
Well, it did get the transaction go through to the 28 that you asked me to send, but I think I accidentally sent it to my my CLI wallet that was already pre-programmed there as an address.
Right. So the snapshot we're looking at on my screen right here and here, just to make it easier to read, let's just do one. Look at this wallet now. This is actually kind of bad news. You just sent a simple transaction out of your NAMI wallet.
Yes.
And what you got as a result is a less ideal UTXO right here. And this is, you didn't have anything to do with this. This is how NAMI is built. And it combined several different native assets in one UTXO. That could lead to problems later, but also maybe it will handle those, right? But these are decisions. It's not magic how UTXOs are being arranged in a wallet. It's all based on the algorithms that we are using. This is called coin selection, if you ever heard that term, right? So the different coin selection algorithms that are used result in the selection of some subset of your UTXOs that fulfills all the requirements of a transaction and creates whatever change is necessary. And depending on the decisions we make there, we may introduce for ourselves like more difficult situations later. But I'm curious to know if this will work even with this UTXO. Now, did your second transaction back to your NAMI, did that one go through yet?
By the way, James, good news. I did try again the commitment. It seems to be working now.
Oh no, we didn't get to see that.
Okay.
Congrats. Okay, so wait, did that happen before or
no,
after?
no. I was running it on pause, so it did come up with the same problem. I could not send the transaction.
Oh, okay.
So even with this new distribution of tokens in my UTXOs, it still is not willing to submit the transaction.
Interesting.
Wait, Claudio, so it worked? The problem that you were having before is now.
No. I thought it was, but it was just because I was running it on debugging mode. It was doing it step by step. It came to the same mistake.
Okay. Because maybe because we talked about the different assets, the different tokens in there that NAMI had shifted around, and maybe that had somehow
So I tried again, but it keeps on refusing to send the transaction for the commitment.
Okay, cool.
So I don't know.
Not cool, but cool for us that are trying.
No, it depends. I was hoping that James would look at the code where I thought it was something to do with the logic when they build the transaction on the front end in PBL, but apparently it's just a problem with my wallet. So I don't know what to do. I tried also with Eternal, but Eternal is even worse because it doesn't even recognize the tokens. There's a problem with addresses, so we cannot really use that.
But now here's the thing though, right? Like on the one hand, where is this problem coming from? UTXO management, it's a wallet side thing, but that's no excuse for app developers, right? We have to assume that these kinds of errors are going to happen, and we have to build applications that can kind of take care, at least handle that with a useful error message. So we've got work ahead of us, both in thinking about wallet design, thinking about coin selection, but also building UIs that are helpful when things don't work out. Did you do the 20 ADA back to your NAMI yet?
I could try that now.
Let's try that one more time.
So James, you're working on the assumption that it has to do with that big, bucket, that big UTXO with all the Lovelace in it. And if you put some in a smaller one, it'll have more. It'll unstick it.
That's a really good first thing to check.
Okay. And what is the error? Like, what can you explain the error in sort of, Newman level terms? Yeah,
Adrian noticed it because this is, if you've been trying to build smart contracts, maybe you've seen this error, especially when you're trying to optimize as much as possible. You do get down to the point of looking at the memory requirements of running a script and looking at what are called the execution units, and that all of that leads to the total transaction fee. So in that kind of messy string of stuff that was in the error message that Claudio had, there was there was a pretty clear line that said, what exactly did it say? Like memory.
Mem minus 3,500, and the minus indicates that it spends 3,500 memory units too much.
Oh, oh, okay. So somewhere in that error message, like that was something that's like, okay, because it was this big giant error message, right? And then there was something that said that maybe the memory, yeah.
Overspent, yes.
Yeah.
Seeing that that
By the way,
Nami,
you can update my UTXOs, the transaction I just
yeah,
sent.
what you can try is to send the contributor token to yourself, but with more loveless in it.
Oh,
Because if I see that Nami wraps tokens together, maybe Nami tried to use a token UTXO for the fees you have to pay.
Oh, even when he sent 20 ADA to himself, I can now see this nice UTXO that you just made. But for some reason, even in that transaction to yourself, it included these other tokens. And I know that because look at you had probably the one, well, there must have been more than one input, but you've got 3 outputs with the same transaction hash. You've got the change, that's what we would expect. You've got the 20 ADA, that's what you tried to send. And then it's throwing these tokens in here like this.
oh, that's very weird.
Is that weird? I mean,
That
they're
is
just
weird.
kind of along for the ride, or?
I wonder if Eternal would do the same thing.
Aha. That's
Right?
thinking like a scientist. Perfect.
You're always trying to isolate, right?
Yeah, that's troubleshooting. Yep.
Okay, but and there's a few branches for us still to explore here, but first, I am curious if this will work. Claudio, can you test that transaction again?
Here on
And
Nami,
actually,
or you want me to table
yeah,
it
from
out?
Nami. Let's try it from Nami. Do you mind sharing screen again? So if there's an error message, we can look at it
Sure.
together.
Sure.
So I'd like to follow this thread for just a moment and let's see. Let's see if either the transaction works now or if there's a new error message.
Okay, so I want to send the 20 again to myself.
You already
So-
did that. So now try the commitment transaction again and see if it works
Oh,
this.
okay.
Fingers crossed. What will happen? Please, as always, no wagering.
Well, the problem here is that
Oh, there it comes up again. You see?
and if you go to the console, what error message are we seeing this time?
So
Just
where should I be? Oh, you want me to do that?
well, it's
Oh,
just
you're-
in the
you're-
yeah, there you go.
That looks
Shitty validation error. Do you want me to expand this? Seems to be the same as before.
Yes. Now, one more thing. This might be a fault of our DApp in its current state, or it might just be the way that because of the way wallets work. Can we try it one more time, but can you refresh the page and reconnect the wallet first?
Okay.
And maybe can you turn off the debugger for now? Because yeah, we don't need.
Okay.
Okay,
Yeah.
all right, so same thing. Okay. So now continuing kind of branching through potential things to look at. We do know that you've made a nicer, smaller UTXO with just 20 ADA and nothing else in it. But we also know that now there's this problem that your contributor token is in a different UTXO. Let's look at that error message again. So same thing, if you open up the console and copy and paste it to the text editor, we could just see if it's the same.
This one, okay.
Yeah, Martin, exactly. So the next step, and you can just, yeah, that's fine. Just delete what's there, replace it.
Yeah, it's just open a new one. So then we can compare.
Very good. That's good too. Notice that this memory negative number is even bigger than last time. Okay, so it's a similar error. But you see,
overspend budget. Yeah.
we exceeded the mem budget by even more than last time. Okay. Now, I think it's likely what Martin is suggesting in the chat, I think is what I would do next. Okay. Try sending now your contributor token to yourself. And ideally, this would separate it into its own UTXO. So if you want to try that.
You want me to send my contributor token with some ADA to myself?
Yeah. Yeah.
Okay.
And that's a good idea. Maybe include a little extra ADA in it. Maybe that'll make a difference.
Let's put 25 to make it different. And I can add the asset here, right? In
Yeah.
This. Okay. And now I put my own address. No, sorry. Oh, I had to copy my address from here, sorry.
Oh, you might have to go back in the NAMI for just a sec.
No, it's okay. I have it in the chat there, sorry.
Oh, you got it. Oh, that's right.
Okay.
Okay, so we'll have to wait a moment for this transaction to be confirmed.
Okay,
Now,
so you want, should I stop sharing and you do something on your end if you want?
no, just we'll wait for that to go through here. I just wanted to share while we're waiting for this. There is a way to solve this error directly in what we write in Mesh. Okay. Basically, Mesh gives us the ability to tweak the cost parameters for building a transaction. And if we increase those numbers a little bit, we can kind of in a automatic way work around this problem when it happens. However, it's not always the best approach, right? You don't want to be, because of the way a wallet works, forcing users of your application to spend more in transaction fees, for example, right? So it's, while on the one hand, it's possible to allow your application to spend a higher transaction fee, I'm not sure what to advise on that. I don't know if anybody has any opinions about that.
What surprises me is because it's always the same commitment transactions. You know, I've done already a couple successfully, so
right.
There wasn't a problem before. So it seems that's why I think it was something intrinsic to the logic of this particular commitment that was being causing the problem.
I agree with that completely. Right. So that's the thing, right? It's the same exact component.
It just went through now. So should I try again with the commitment?
Yeah, and refresh the page just to make sure that that's not a problem.
Get rid of this. Just to make sure.
Over here, I'm going to check. I'm just taking a look at your wallet to see if we do have a split UTXO now. Good. Okay. So right now, yeah, you've got a UTXO with 25 ADA and your contributor token. Let's see if that works. Yeah.
Yes, there we go.
All right. So a terrible user experience, right?
Indeed.
And it's hard to know exactly where to put fault for this, but I hope that people can kind of see through the things that we could be frustrated about and recognize opportunities.
I guess
here.
it would be fair for, I don't know, you or whoever seems more appropriate to communicate this to the NAMI team for them to consider
Yeah.
their coin selection, because if it's only that, it's at least you should give a more informative error description so we know what to do. I mean, I would have never guessed about this if you haven't told me.
That's right. That's right. Yeah, I'm a little bit surprised, and I want to go explore, yeah, the NAMI Discord just to see if there's been a previous conversation about coin selection when you're sending a simple transaction. Yeah, the one thing that doesn't feel right to me is the fact that those tokens were combined on a very simple transaction. But on the other hand, there's, it can be, if you want to have a performant wallet, it's really nice to have at least a handful of UTXOs that are maybe in the 5 to 50 ADA and nothing else range. That's going to make it more likely that your wallet can pick things up. And by extension, this is a decision you could make when you're building an application. So for example, I'm going to pull this up on my screen to illustrate this idea. So there's this is the JavaScript or the React component. It's a TSX, so TypeScript React file. And this is where we are building the commitment transaction that Claudio just ran, okay? Now, before we can look at the details of this, and it's really exciting to be starting to look at this together. And this is going to be kind of our mystery text for a few weeks to come as we all learn what's going on here. But as an application developer, one decision I could make right here is just to add an output back to the user that sends them 25 ADA and nothing else to themselves. And I could argue to myself that one reason to do that is that I'm trying to help people set up their wallet with a nice UTXO distribution that's better off in the future. Now, the problem with what I just described is that not everybody has even 25 ADA in their wallet. So I probably wouldn't want to do that. And I could add a little bit more logic. But the reason I'm saying all of this is because that's a choice I could make, right? I could just have a good-willed application that when people use it, they also end up with tidier UTXOs. The big argument against that is should I really be expressing that much of an opinion against people's, without people knowing about it? Do people have questions about that, what I just shared right there? Okay. The other thing, like I mentioned, and I need to check my notes. I'm actually not prepared to talk about this on the fly right now. we could dive into the docs, but there are ways as we put this transaction together to change or adjust the cost model for these transactions so that if necessary, we would pay a higher fee to make sure that the memory requirements are met. That's also, that's kind of it. I don't know what best practices are there. Has anybody else been thinking about that? Yeah, Juan.
Yes, I was thinking about that because I faced this problem before. Here you have two paths. The problem is not the fee. The problem is that in order to avoid attacks on nodes, all the memory and the computation is limited in the script. You must pay more when the computation and the memory usage is more, but you have a limit. And the problem here, I think that we get this limit. I think I think there is one way, because all Cardano transactions are deterministic. So I don't know how mesh internally work, but you need to calculate the budget. So it's called these two numbers, memory and CPU. And with these two numbers, you can calculate the fee. So mesh can warning you that you are exceeding the protocol parameters of maximum memory or maximum CPU or both.
Yes.
So in the coin selection part, because this is not all fault of NAMI, because other interaction can produce this UTXO with a lot of NFT and so on. And when you program the script in PluTX or whatever you are doing, you always test it in the nice way. One UTXO, minimum NFTs and assets in your wallet. So you practically work on the minimum budget.
Right.
So I was thinking about it, and maybe in the future, sure, there is some CIP about that, but we need some preparation stage to execute our scripts. We need to meet this condition before you send the contract execution.
Yes, well said. Well said.
So I think in the near future, we can also, maybe the mesh guys provide us some kind of preconditional calculus to avoid this situation. And this could be something like, okay, I'm going to execute this script, but for this script, I need maximal 2 UTXO and no more than 5 asset, sorry, and so we can guarantee that the execution pass through.
Yes.
So that's it. Those are my thoughts.
Okay, good. So first of all, 100%. And what you're kind of describing some potential next steps in mesh development. And I just want people to know, I mentioned this idea earlier of we're blurring the lines between specialization and contribution. And we're working really closely with the mesh team right now to build, they're kind of helping out with the building of first a course module for the 300 level in this course. And they're going to create their own course in a similar way that culminates in further contribution to the mesh platform. Okay, so these opportunities for all of us to learn more deeply about mesh and I think critically contribute to it are coming. And so I'm just so excited about how this conversation is going, because we're getting into like deeply into the cutting edge of mesh development right now. Thank you for this. With that in mind of where we're going, I want to show you just a little bit about this. You can see from mesh, this commitment component does import an action. An action has a budget indicated inside of it. And so I want to show you two things. I want to show you where this is used in this file. And then I'd like to show you a bit more about what, like, context for what Juan was just talking about. If I search for action, it's going to find transaction as well, but let's just go down. Okay, so we're using action as the type for actually our redeemer. The idea of redeemer might still be brand new to people, but that's also coming. And let's see, where do we then define that redeemer? Down here. Okay, so action, we're using it for our redeemer, right? And redeemer is basically in a Plutus validator, the redeemer is where we state our intentions for interacting with a smart contract. Okay, basically at transaction building time, whoever is building the transaction can say, hey, I want to interact with your contract this way versus that way, right? I want to buy or sell. I want to lock or unlock. The list could go. I want to commit or distribute, for example. Okay, it can be a statement of intent, but the mesh action object that we're using to define our redeemer can also state some things that go beyond the direct validation interactions. Okay, so we can use this data right here. This gets passed to the Plutus contract. And as we look at the Plutus contract, we're going to revisit this bit right here and see more about it. But I want to look at this action data type in depth. Okay, so this is, I'm in the node modules directory of the project. This is the source code that's downloaded into my project when I install mesh in my project. And you can see the type action is defined here. Data is data, which is itself a separate type. Budget looks like it's defined somewhere else as well. But notice when I mouse over this, let's see if we can find it directly. It's defined, it's right below. This is defined right here. And here you can see exactly what Juan was just talking about. Memory and steps, each of which are a numeric value. Okay. So what we're basically looking at right here is when you define a redeemer in the off-chain code, for example, the mesh code of your application, this is allowing us to change those budget values. And so by including a line like this, budget, lowercase b, right? Budget. And is that an object? Yeah. And I could put some number here and some number here, right? This is how you would tweak from inside your application those budget parameters and maybe give us a way to get around the problem Claudio was just showing us. The problem is, once again, this could result in just paying higher transaction. Sorry, Juan, is it transaction fees or is it min UTXOs that I should be saying right there?
What do you mean? Sorry?
If I raise these, if I place higher values here for memory and steps, do I risk charging a higher transaction fee or just raising the min UTXO?
No, the fees are bigger. There
The
are
fees will
some
be bigger.
protocol
Yeah.
parameters where you can see how much cost each unit there.
That's what I thought. Okay, so I could increase the reliability of this application by putting higher numbers here and here. And I have to check for the context of like what those should be. So just for now, we can recognize I can change these values. If I do, maybe Claudio never sees that problem, right? And his commitment transaction works every time, but he would be paying a higher fee than necessary. And as a builder, do I want to make that trade-off? I could argue yes or no, and it's something for all of us to think about. Erez, what do you think?
Yeah, hey, I'm just wondering why do you think the designers use the name Redeemer instead of something else? Like what is being redeemed?
Okay, excellent. That's a great question. So I'm not going to leave this change here. Let's go back down to where we're building the transaction. And it's interesting. So yes, the designers of Plutus used the word Redeemer, right? And it's just now a standard part of validation. If you've looked at another smart contract language, you've probably seen Redeemer there as well. But you also can see it being used by the mesh team. So in their transaction builder, you're able to add a redeem value function to that. Okay. Now, why do we call this redeem? I can't go all the way back to the drawing board and speak for why it was originally chosen, but it makes sense to me because whenever you're using a redeemer, it's in an unlocking transaction, right? I do not need to specify a redeemer to lock tokens at a UTXO. But after they're locked in a contract address, the unlocking transaction, I think that is like an act of I'm redeeming something, right? Like if I have a coupon that's redeemable for this discount at this store or for admission, right? I'm gonna redeem my event ticket to get in. I could see that logically making sense, right? And so, yeah, at a really high level, and I know that everybody's at a different place right now. I just want you to know that this is at the core of everything we're going to do together for as long as we decide to keep learning together. Okay. So I just want you to know that there's no expectation that you've mastered transaction building, especially with smart contracts yet, but we're getting there. And the project in 204 is going to give you an example that we're going to continue to look at together. And as we move into specializing, we're going to look at transaction interactions, both with Cardano CLI and with Mesh. So for now, just to wrap, this is a nice high-level view of what we need to do. Okay, so don't worry about all the details, but just notice we're going to build a transaction that redeems value from one place, in this case, a treasury contract, and it sends value elsewhere, right? This example has one UTXO in from a contract, and it's specifying two different places to send value, right? Some value back to the treasury, some value to the escrow. But I could also send value or send assets to a wallet address. For example, the contributor's wallet address. And if we look at the companion transaction to this one, which is the distribution, right? This is the one that happens when a teacher sees that you've finished a commitment and you get your token back. This is actually a more complicated transaction. And just so you can see this, notice that this transaction build right here has two redeem values. It's redeeming from the escrow contract, what was locked there, your contributor token, and maybe some additional tokens that will accompany the completion of this task or commitment. And then there's another redeem value from the reference UTXO. This is at the contract address that's holding the reference token associated with your PPBL token. Everybody minted a token in module 100. And when you did, you got one token in your wallet, but another token with almost the same name was sent to a contract address. And in the UTXO with that token is held your datum, your lucky number, and the list of modules you've completed. When we distribute, we want to update that datum. Right? We want to add the new modules that you've completed to your mastery datum. And in order to do that, we have to unlock the UTXO that currently holds your reference token and reference datum. And we have to write new datum, updated datum, and send it back to that address. Okay. And finally, we got to send some value back to you. We got to send you your contributor token and any additional tokens that were locked in the escrow UTXO. So 2 redeems and 1, 2, 3 sends in this transaction right here. All right, we're going to keep going with this, but does anybody have any questions before we wrap today? I can stick around for a little bit if anybody has any immediate questions based on what you're seeing here.
Oh man, I had to bounce out, but I came back in, I guess, just to catch the last bit. I will watch the video and work on the magic number for next week.
Rock and roll. And yeah, just the one thing I want to make sure everybody knows, this is just the beginning of talking about this bit right here. All right. I don't want anybody to feel like you're overwhelmed right now, which means you're doing it wrong. If you're overwhelmed right now, you're in exactly the right spot. Okay. And we're gonna look at this together in a bunch of different contexts over the next few weeks. And of course, we also have to look at the Plutus code against which we are redeeming right here. We're going to do that as well, as much as we can each week, little by little. All right, so just whatever questions you have, keep them coming. But I'm excited that we're starting to get to the good stuff here.
Yeah.
Hey, James, a quick question. So in the previous discussion, there was like the memory that was being talked about, right? So what exactly is this memory?
Okay, good. This is, so we can see in this budget, where was it? I can go up to it. We can see this action thing, and we can see that action has a budget. And if I go look at how action is defined, I can see how budget is defined with mem and steps. Okay, but let's look at this from a slightly different perspective. You know how you have to download that protocol params file when you're using Cardano CLI? Let's look at that file for a minute. Modules open. I was looking.
Oh, okay.
This is the protocol.json file that you have to have if you're building smart contract interactions on Cardano CLI. it used to be you needed this for every single kind of transaction, but at this point, Cardano CLI has been developed beyond that point. And so there's some very simple transactions you can build without including a reference to the protocol JSON file. But for the most part, this is, we want this. And you see how there's this big object right here. It goes from lines 3 to 340. There's 340 plus lines of cost models inside of this parameters file. And there's all sorts of little, parameters here that all of it combines to determine how much a transaction is going to cost. All right, so, but without getting too distracted by all of those details, we can see the cost model is different for Plutus V1 versus Plutus V2. And then we can also see down a little farther, there's this bit, execution unit prices with memory and steps. We can see block execution units with memory and steps. Transaction execution units, same two things, okay? And those are exactly the two things that are being specified in budget right here, memory and steps, okay? And so basically what this allows us to do is, I guess these are maximums. These are straight up parameters, pretty small numbers. This is like 0.00577, right? And are these, somebody help me out here, these are amounts of Lovelaces, right? The price?
Yes.
Yeah. So per memory unit, 0.0057, so like 5,770 Lovelace per memory unit, however those are defined, and per step, an even smaller number, 721 Lovelace. Yeah, so those are parameters, and these are not adjustable. These are prices. That's not what we're tweaking. These are maximum limits for what memory and steps could be right here. And so basically there's some default value for each of these that we could dig in and probably find somewhere. I have to look for that. But you can change them in the redeemers you write. We need a good this is something to think about, and anybody who's puzzling over this right now, whether you understand it or not, I would be really interested in building a helpful exploration of this that somebody can kind of play with and understand a little better, because I don't understand it well enough yet. Yeah, okay, and Newman, you're right. I'm actually confused by this number, I got to admit, because I thought that ADA was only defined to 6 decimal places, but this number right here, this seems to indicate 7 decimal places. So does it get rounded?
Yeah. No idea. I could ask ChatGPT again. I mean, this could be, because it says price steps and price memory. I guess, those are units of ADA, of Lovelace.
But the rounding would seem to be a non-deterministic operation.
Right.
Well, I guess you always know it's deterministic how you're going to round if you know the other inputs, I guess. So, but that's a little surprising.
That's a price per step. So there will be multiple steps.
Right.
So you will add up 50 of whatever they are.
Yeah. But what if it was 53? If I had 53 steps at this cost per step, to multiply that directly, I'm going to end up with a price that has 7 decimal points of significance, but I can only indicate 6 of those on chain. Yes, the professor. This is who we need. Mix, what do you think?
Hello, everyone. The steps are referring to picosecond, and picosecond is the time for execution in CPU. So if you can see a line 365, it's around 10 billion a step, which means for execution of a smart contract, or namely block, network doesn't allow you for more than 10 billion picoseconds. You can, I think it would be 1 because pico is 10 power 12, if I remember correctly. And that number per price a step, I don't know any name for it. It's not Lovelace, but if you add enough million or millions of steps, which normally is the normal. If you send something even by wallet, it will cost something, some execution, some computation. And as I said, it's picosecond, so it's very, very small time scale. So it will reach to something on Lovelace. But yeah, I mean, I don't know any name for that because if let's say it's 1 picosecond if execution, which is very unlikely. But if it happens, well, we don't have that. And even the protocol doesn't allow you to pay a fee less than a number, which I don't have it on top of my mind. So there is a limitation for lower fee as well. I think 172 or 62,000 Lovelace. So at the minimum fee, you cannot go under that. It is a protocol violation. So somehow it will reach to the Lovelace, but we will see in future maybe, or I don't know, maybe for some Hydra stuff, we will have some issue and we have to update the protocol. But yeah, the step means picosecond, and each of them represent the price for picoseconds.
Picosecond, and you said picosecond is 1/10 to the 12th of.
Yeah, if I remember correctly, if you guys can check it out, nano is 10 power 9, and by the 9 I mean -9 for for the smaller scale. So pico is 10 power -12.
Yes. Okay. All right. So yeah, with units that with steps being that small a length of compute time, you're gonna multiply this by at least 1 order of magnitude, and likely a lot more than that. And that's enough to make sure these are Lovelace. But yeah, still, you're right. We need a name to talk about these smaller units just in case.
And the information is as a kind of comment in one of the Plutus source code. So, I found that there. So it's not very straightforward.
Actually, you can calculate the maximum fee.
Yeah, it would be around 2 ADA, I think. I mean, at least the protocol. I mean, by the way, there is an execution memory fee, which at the transaction builder you are going to see, and it might reach like 3 ADA or 4 ADA. It's fine there. It doesn't fail. But once you are going to submit the transaction, you cannot pass 2 ADA for some reason. I mean, it's a protocol rule again. So you can calculate something and you will reach something, and even about the size of transaction, or creating a big smart contract you want to deploy it on Ledger. So for example, normally it's 50 ADA, 30 ADA for putting that smart contract in UTXO. But if your smart contract is too big, the transaction will ask you need to lock 200 ADA or something like that much big, but and it passed, so there is no problem. But once you reach the submission level, it doesn't allow you, and it say that you cannot pass 2 ADA. And again, 2 ADA, I saw that in Plutus source code. So There is a hidden word there if you guys want to check it out.
It's in the Plutus source code.
Yeah, I see those comments, you know, the Haddock will show you the nice one, but if you go to the source code of those codes inside the Plutus libraries of on-chain, off-chain, the comments inside them will really explain why this decision or why this number exists actually. But you guys can check it out. That's something interesting. You can, like, for example, create a very big smart contract, like let's say 40 kilobyte, something like, yeah, and you can just create a very simple smart contract, and at the error message or trace if else, put a very, very big string, and it will compile. It doesn't complain. And you will end up with very big smart contract, and try to put that in a smart inside a UTXO, like you know, as an inline script. And then you will see that the transaction will ask you like 200 ADA or 100 something ADA. I'm going to ask you, and it shows the fees. Wow, the fee is expensive as well. It's 3 ADA or something. But once you are going to reach to a submission level, that doesn't allow you. And the error will tell you that, hey, you are passing 2 ADA.
This is great. Well, I've got questions and things I want to explore. Anybody else?
And about the Volter era, we are going to see all this decision happening here. By the way, I mean, with the Conway era, the protocol version will be 9, and there will be some changes about the cost model. So the protocol version, major, minor, this will change. This is for Valentine.
I was going to mention that too. We noticed yesterday that the new version of Cardano node was now 8 all of a sudden, skipping from 135.6, 135.7 to 8. And the reason for that is to align the node numbering with the protocol version numbering.
I see. So that's
it was kind of jarring to see that change all at once, but that's the reasoning for it. And I guess it's a good thing moving forward.
So if there is a minor change, they are going to release a new protocol for those minor changes as well, like something.
Oh, I can't speak for protocol minor changes, but you can imagine that node, like updates to Cardano node, are still going to be more frequent than updates to the protocol, right?
Yeah.
So we'll have, but at least we'll be able to say, okay, this is version 8.0 of Cardano node is the first Cardano node that was released specifically for protocol version 8. And you would number from there. And then when the whole protocol upgrades for the Conway era, Cardano node versions would be 9, et cetera.
Okay, interesting. You'll see that.
All right. Well, I hope that people have enough to explore.
James, if is that your are you sharing this or someone else? I mean, are you sharing this? I mean, what we are seeing, this is the protocol version.
Oh yeah, I'm sharing the screen right here.
So this is the link I'm sharing. Would you please click that? This link tell you about that execution step, which is EXCPU, and it says that count CPU unit in picosecond, maximum value for so that's which is 100. But anyway, so you see that this explanation about that are in the Plutus documentation, namely comment.
Okay, so how many picoseconds are there in 106 days? I learned that today.
That's you know, 2 power 63 minus 1 normally is the power for I think the space or capacity for 16 or 32 bytes. So
Okay.
the digit cannot go past through that, like, because they are considering the CPUs are like 86 x86. They are not 64. So, or maybe if you see with the changes with the node, you are seeing that the requirement changes as well. So, like for example, now we need 24 gigabyte of RAM. Before it was 16 gigabytes. So now
Yeah.
things are changing. So this number will change, but for now, for the limitation of the CPUs or whatever, we have that. But we won't reach that. Like 106 days for execution of one script or one. That's,
That would be a problem.
yeah. That's an attack. You know, if someone can find something like this, because there is a loop. You can create a loop inside your smart contract and send it and submit, and everything's fine. But after reaching a level, the node, the first node normally, not your node, because you will pass it in your mempool, but the node, the second node, will try to execute it and say, hey, oh, I'm reaching the limitation, and it will consume your collateral, sending back the leftover to your account and failing. So one of the things you can fail your transaction is create a loop, create something that will pass this execution steps.
Mm-hmm. And Mix, I know you've been building some bash scripts that give people a little bit more insight to these.
Haskell script.
Those are Haskell scripts, even better. Okay, so we'll all get to look at those together pretty soon. Definitely. As we start to dig a little deeper into Plutus. Sure. All right. But I think we've packed enough in for today. And thank you everybody for staying overtime. I hope this is helpful. Just keep in mind that wherever you are in the course right now, it's made to be self-paced. So if you're at module 102 or 203 or anywhere in between, you're in great shape. I'm really excited to see what questions people come up with as you start getting into 202, 203, 204, because everything that's there is designed to drive us to the questions that are going to be at the focus of what we all do together in module 300. So keep it up. Make sure to write down questions when you have them, either by sharing them right away on Discord or by just bringing them to these live coding sessions. And we're going to keep bridging that gap between learning and specializing and contributing over the next few weeks. I'm looking forward to it. Thanks again. See you soon.